Good morning, students. Welcome back to your online mathematics class. So I had told you in the previous video what is complex number, how is a complex number defined, okay, and various questions we have solved, addition, subtraction, division, all this we have done. Now today we will study modulus of a complex number. Alright, so we will study today modulus of a complex number. So as the title you can see modulus. Okay, so first let z is equal to a plus ib, a complex number, because this is the form of a complex number. Okay, don't forget we have done this and explained previously in the videos. Okay, so let the complex number be z is equal to a plus ib. Now modulus of z is denoted by this. Okay, these parallel bars on both sides. So this is modulus of z. So this is written as a plus ib in this bars. Okay, so the value of this means you will take square of the real part and add square of the imaginary part and take its square root. Are you following, students? So modulus z is equal to square root of a square plus b square. What is a? Okay, so real z, okay, is your a, okay, and imaginary z is your b. Alright, so square of the real part plus square of the imaginary part and its under root. Okay, so this is modulus of a complex number. This notation, okay, is modulus. Modulus of what? Modulus of a complex number. Okay, modulus. 1 minute, I'll just write this. Modulus. Okay, this is S, modulus of a complex number. Are you following, students? Modulus of a complex number. The notation is this. Now for example, if I take z is equal to 3 plus 4i. Okay, so I have to calculate modulus z. So modulus z is equal to modulus of 3 plus 4i. Okay, so this will be square of the real part. What is this? 3 real part. Okay, so 3 square plus 4 square and its under root. So which is equal to 3 square is 9, 4 square is 16 and under root. So 9 plus 16 is equal to root 25, which is equal to 5. Are you following, students? Okay, let me take one more example so it will be clear. Suppose if I take another complex number, z is equal to 4 minus 3i. Okay, 4 minus 3i. So now I have to calculate modulus. So modulus z means I will write like this: 4 minus 3i modulus. Okay, which is equal to, okay, this you can rewrite as 4 plus minus 3i. Right, this equation you can rewrite as 4 plus minus 3. So square of the real part plus square of the imaginary part and its square root. So 4 square is 16, minus 3 square is 9. 16 plus 9 is equal to root 25, which is equal to 5. Are you following, students? So you see here, I'll change the markering 1 minute. You can differentiate now easily. Okay, see this complex number z is equal to 3 plus 4i, right? And see this is z is equal to 4 minus 3i. Alright, this means if you see that modulus, in both the cases the modulus of z is what? 5. And always remember it is positive, okay, non-negative real number. Modulus of a complex number is always non-negative real number. Okay, so plus this minus 3 will become plus, see, minus 3 whole square. Okay, this is becoming positive. Okay, even if I take z is equal to, okay, see, suppose if I take z is equal to 3 minus 4i. Okay, so I can rewrite this as z is equal to 3 plus minus 4i. So modulus of z will be what? Modulus of 3 minus 4i. So again same thing, square of the real part, 3 square plus minus imaginary part square and under root. So 3 square is 9 and minus 4 square will be 16. So 9 plus 16 is 25, okay, is equal to root 25, which is equal to 5. Are you following, students? Clear to all? So you see what we are doing in this Z. See this one complex number, the second complex number, and this third complex number. So in all the three, the value of modulus Z is same. See 5, 5 and 5. So what does this show? This shows that for modulus Z, we take square of the real part, square of the real part and square of the imaginary part and under root. See 3 and 4 or 3 and minus 4. This minus 4 will become positive and see here this minus 3 will become positive. So real part and imaginary part, irrespective of the sign, does not make any difference because negative will become square. Okay, see this is 3 plus 4i, imaginary part is positive. Alright, see here imaginary part is negative, minus 4i. So it does not make any difference because this minus 4 will become positive. Okay, and see here this real this 3 plus 4i, again same thing, and minus 3i, again the imaginary part is negative. Okay, so this minus 3 will become positive. See here minus 3 whole square positive. So we are getting 16 plus 9, 9 plus 16, 9 plus 16. Ultimately, the modulus is same, 5, 5 and 5. So what I am trying to explain to students, that modulus of Z is square, okay, square of the real part and the sum of imaginary part and its square root. So 3 and 4 square, okay, even if it is negative then also it will be same. Alright, so 3 plus 4i, modulus is 5, modulus of 4 minus 3i is 5 and modulus of 3 minus 4i is 5. Okay, so real part and imaginary part is not making any difference, okay, even if they're interchanged with the signs. Suppose if I ask you what is the value of 3 plus 5, so 3 plus 5 is what? 8, and if I say what is the value of 5 plus 3, that is also 8. Okay, so are you following, students? So square of the real part and sum of the square of the imaginary part and the square root is your modulus. Okay, so in next video I will explain you how to solve questions. So remember this concept clearly. Then I will tell you conjugate of a complex number and multiplicative inverse also. So all the best, study well.